Okay. So we talked a little bit about input and output. And by the way, I'm probably not going to give you an assignment today because we're a little bit behind. So I'll probably do that Thursday during lab because I want to get to the point where we're all kind of closer to actually be able to do something. So having said that, everybody's like, oh, damn it. But I want to talk about basic input and output. So we talked a little bit about it already. Let me get my idle program up here. And then let me move stuff around. Excuse me. I am on drugs. Not the fun kind, but the I've had the flu kind. So I want to talk about basic input and output. So, what I need to do is I need to share. I don't have enough. There we go. So you should be able to see my Python shell, right? Yes, good. Okay. I need another monitor, I think. I need more room. So let me open a file. And let me go here. Where am I? There I am. And let equation program. So let me run it again. And remember that the Drake equation was what percentage of stars do you think have planets? No, that's not the program. The program is to figure out how many civilizations there are that we could possibly contact in the universe. And it's a real equation. It's used by, what's going on? Let me stop share. I'm having technical difficulties. My Zoom program has stopped responding.
Oh, yeah. Also, your screen doesn't show up, like your face.
If your Zoom audio is still active, Zoom has a lot of problems with focus. You're best off closing every single possible application and keeping your mouse only over the Zoom window. I had to do an audit last week, an external audit for 8 hours. God damn, it was like.
Okay, Patrick, for some reason you are now muted. Okay, so I had an issue where my Zoom meeting basically crashed. Basically it said it stopped responding. So I don't know. Could you guys still see me and hear me or no? You
Yeah.
could?
Yeah, we can see you.
You could see me? You couldn't hear me?
Right.
Or could
We
you?
could see you until it crashed, and then when
Yeah.
it crashed, you froze. And
I
then
froze?
you came back.
Okay. Okay. Because I was waiting for it to respond instead of closing it, but then it took a little bit longer than I was willing to give. And that's the first time that that's happened, obviously to us, you know that. And the reason I saw it is because when I share a screen, I see little thumbnails of your faces or your names, and all of a sudden it went blank. So now let's try to get back into the Drake equation. And here I am. Okay. Oh, I got to share the screen. Share screen. Screen 2. Hopefully that's not what's causing it to die. Okay. So am I still recording? I got to make sure everything is good again. Recording to the cloud. Okay, so it seems to be okay. So I'm not exactly sure what happened. This hasn't happened to any of my Zoom classes ever. So I apologize, and I don't know what, it just did weird crap. So I was talking about the Drake equation, and the last thing that I was saying was that it's a real equation. It's a real recognized kind of mathematical calculation that can be used to, in reality, figure out how many, it's a little bit controversial, but not really, how many other civilizations there might be in the galaxy that we could contact. And the thing that's interesting about this program is because it lets us, it takes input from the user, and then it does something to the input. And in this case, it does math to the input. And I'm sorry, I'm looking for something. There it is. I'm looking for the remote for the fan because it's on and I'm freezing cold. It does a calculation and then it produces some output. So that's kind of the basics of what a computer does. It takes input, does some processing to it, and processing is whatever, depending on what kind of program we're using. And then it creates output for us. And that's the very basics. It's an input-output system. It's a bit like a toaster. You input something, you do some processing. What kind of processing does a toaster do? Okay, so what's the input for a toaster? Yes, good. Giovanna and Angelina got it. The processing is applying heat. The input would be some type of bready thing. Could be a toaster strudel. But let's go with bread. So we have a slice of bread, right? We put it in the toaster. We press the little button. It applies heat. What's our output? Toast, yes. So toast is bread that's had heat applied to it, so it's crunchy on the outside and soft on the inside, and it's delicious. I don't know anybody that hates toast. So that's input going to output. all programs. If you open Word and you start typing something, that's your input. If you press the bold button, that's part of processing, right? If you press bold, you make something bold, you do spell check, you center things, right? So processing, we're doing stuff to our input. And then we create our output, which is our finished Word document. So here, it's illustrating how we can deal with input and output. So first off, in order for this program to do the processing that it needs to do, it needs some numbers, right? So it needs, it needs a whole bunch. So what's this one say? What percentage of stars do you think have planets? So I'm just going to go with 70%, say. So I enter 70. Now, here I have a basic user interface, which is a command line interface, and I've modified it a little bit so that I can, the user, I should say the user, we should talk about user and programmer, so that the user understands what it is that they're supposed to do. I'm trying to make this as clear as possible for the person using the program. So how many planets per star do you think can support life? So I'll go with, well, let's go with 3. I want to get a bigger answer. What percentage do you think actually develop life? So out of the planets that can support life, what percentage of those do I think actually, and by the way, there are, like if you go to astronomy websites or you get on Google, you can actually find some fairly good guesstimates for these things. And so you can get a more valid kind of result. What percentage do I actually think develop life? So let's say that I'm going to go with 60%. Like I said, I'm being optimistic today. What percentage of those do you think have intelligent life? So not just like little bacteria floating around in the atmosphere, but intelligent life. So out of the 60%, I'm going to say half of those. So 50. And then I press enter. And lastly, I think that's the last question. What percentage of those do you think can communicate with us? So let's say half of those. Oh, the number of years you think civilizations last. So we have a time element here. So let's go with 15,000 years. Enter. So what's happened once I entered the last piece of input is that the program has done some processing. So basically it did a math problem, a calculation, and then it's returned some output, and the output is formatted. So in this case, the output, like instead of it just saying 33,075, I've formatted that output so that it has some context. Now, obviously, it has inherent context because of the program. So we already kind of know what the 33,075 represents. But again, I'm kind of making it nicer. So based on the values entered, there are an estimated 33,075 potentially detectable civilizations in our galaxy. So let's take a look at how we work with input and output. So my real code starts here. And basically, this is that welcome part. So we talked about kind of the in my book, 3 parts of programming, but in Python, it's important to have, since we don't have a regular user interface, it's important to have kind of a text-based welcome to the program kind of a thing, which basically explains what the program is supposed to do. So this is good for the user because the end user may not know exactly what it is, how the program should work. which is another reason why we do the input in this case the way we did. We have to be careful because in programming, there are two times really. There's what we call design time, which in this case is where I'm at. This is where I can edit the program. I can write code. I can, decide what it is that I want the program, how I want it to look. So that's basically design time, writing code. That's when you're being the programmer. So when we're programming, we really have two people that we have to be too. We have to kind of have a split personality. So we have to be the programmer, the person creating the program. Now in the real world, big programs, or most programs, a program like Word, for instance, there isn't one programmer that created Word. There is a whole group of programmers that are working on different parts of the program because it's so big and has so many features. So a lot of things that we do in programming is because most programs are created using multiple people are working on it, multiple programmers. So a lot of times when we comment stuff within our code, it's because we assume that at some point another programmer is going to look at what we have, and then we want to have explanations of what it is that we're doing where, what am I working on here, because we don't want the other programmer to have to really what is going on, right? And take 3 minutes, 4 minutes to figure out what's going on with this chunk of code. So we just remark it. So here where it says get user input, right? That's a remark. It's saying, hey, this is what's happening here. Now, again, this is kind of a simple program. So, our remarks are kind of simple. We can remark individual lines of code if we feel like it. But a lot of things that we do are just because they are standards and because in the real world, like I said, other people, other programmers, other people who aren't programmers, but are kind of like group supervisors or something, maybe looking at our code too, and we want to explain in English what's going on where. So that's a big thing to remember. We're doing a lot of stuff because even though you guys are working on stuff individually, it's your own program, we're still going to kind of follow the basic rules. So we're going to remark stuff, and there'll at least be one person that looks at it, and that'll be me. So having said that, that's when we're in design time. We're in our programmer mode. Now, when we enter runtime, when I actually run this program, and I'll get back to explaining the code here. When I get here, now I have to pretend that I'm an end user. I'm somebody using the program. Because most programs are made, again, in the real world and not in the classroom setting, most programs have a purpose. So in our case, we're going to pretend that we want to use the program. We are a user, right? And users don't know and don't care how the program was created, coded. They just see the end product. This is a little bit difficult to do, which is why most programs are tested, beta tested, sent out to people who to test the program. Because it's difficult for programmers to pretend that they're end users and don't know anything about how the program was created or why, this is important, why the program works the way it does. For instance, I don't really know why in Word making something bold is a button. I can guess, but I don't know what the thought process was behind making it a button. I can guess why, but as an end user, I don't really care. It's a button. Does it work? Does it make sense? Can I use the program and use it incorrectly easily? Can I screw it up? Can I do something that's not logical? Okay, so, and again, this is kind of difficult to explain. As a programmer, when we test our programs, we know the thought process behind why we did certain things. Right? We said, well, I need user input, so I'm going to start off with what percentage of stars do you think have planets? And so I'm just going to have these questions. The user doesn't know how many questions there are if they've used the program only once, in this case, or they've never used it before. They don't know why we've done it this way. They don't care. And so it's difficult for us as programmers because we already know those things. It's difficult for us to really 100% put ourselves in an end user position. So remember that in programming there are two times. There's design time, and where I am now, which is runtime, the program is actually running. And that we kind of have to put ourselves in two seats. Now, the programmer part is relatively easy to put yourself in. I mean, it can be hard. It's when you're writing code. The difficult one is trying to, when you're evaluating a program that you've created, to whether or not it works the way it's supposed to. We talked about logic errors and syntax errors. Syntax errors are on the programming side, whereas logic errors are really recognized by pretending that we're an end user. Because remember that logic errors are things like, you know, what did I get, 33,075? Like if that number was incorrect because I had written, as the programmer, had written the calculation incorrectly, that's a logic error. Logic errors are difficult to find. So that's why we test our programs with known inputs so that we then can get a known output and double check to make sure that our numbers are right, especially when we're doing calculations. So, so let me close this. So this is my user interface. Yes, I want to kill it. So this is the first part. So the first part is using the print, and I really haven't talked about, you know, actual lines of code. So here's how it works. The word print will put something onto the screen. It will output it to the monitor, basically. It'll show it on the screen. So you can see the first part here. Each line has a print command in front of it. Now, in parentheses is what we want to print, what we want to output to the screen. And I'm just going to I'm going to add a line here. Okay, so I'm actually adding 3 lines. And so if I want to print something, I want to show something on the screen, I'm going to use the print command. So type in print. It's not technically necessary, but it is a norm to use a space after the print. And then I do my opening parentheses. And notice that as soon as I do that parentheses, it says print value, comma, dot, 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 separator equals end, you know, /n, file system, flush, false. So basically what it's doing is it's showing me the layout of what goes into the parentheses. Now, we don't understand all of that stuff. And we don't have to. It's just kind of a reminder that this is the format of how it should look. And we'll talk about like and separators and that kind of stuff at some point also. So having said that, I'm going to type in what it is that I want to print. Now, in this case, it's going to be what we call a literal. A literal basically means that it's literally what I put in. So whenever we work with literals, in this case, a piece of text that's a literal, I have to put things in quotation marks. And I'm going to do this a lot, and I did this the last time we talked a little bit about this, and I was showing you an example. For the past 14 years, I've been doing quotation marks like this, and Python can use these or these. So it can use single quotations or double quotations, but you have to be consistent. So if you have a double quotation at the beginning, you need to have a double quotation at the end. If you have a single quotation, you have a single quotation. You can use either or. And my problem is that I screw it up because it's the same key except one's shift and one's not. And so I tend to screw it up because I press shift kind of automatically. It's a reflex action. So I'm going to type in here, created by, and this is a literal, it turns green, by me. Now, if I'm going to do this on purpose, oops, I don't know what just happened. And I close the parentheses. Now the problem is look, my parentheses is still green. The closing parentheses is green. You can see that, right? I'm not just like, okay. And that's because it's expecting another literal, because I used a double quotation mark. So it's expecting something in between a double quotation mark and then the single quotation mark to end. So I could say, you know, I could quote somebody inside a, Bob said, right? So single quotation mark, Bob said, double quotation mark, go to school, double quotation mark, single quotation mark, close parentheses. So that would actually print, output the quotation marks. Does that make sense? So I'm going to fix this because I don't want with a single quotation mark, and then close my parentheses. So this literal right here, it's not going to do the quotation marks, is going to show up on my screen. I'll go ahead and run this. Oh, and I need to save the changes so I can, it's going to prompt me if I run it without saving something. So, and I've already given it a name. So I'll just go ahead and say okay. And then it runs it, and you can see that that first line was now added. Now, look at the rest of these lines, because I want to show you that unlike in Word, Python will not automatically wrap text. So in order to get this to show up like this, I had to create a print line for each one of these, just so that it wouldn't be so long and not wrap automatically. So let me close this. And that's why I've set this up like this. Okay, and so each one of these lines is a print command inside its own parentheses and quotation marks. And the reason I did it is so that I don't have one really long line. I can control the kind of the wrap. Having said that, I have this one. So what is this doing? Why do I have this print with empty parentheses at the end? I like Patrick's answer because I know what it means. Patrick is correct. Basically, it's a blank line. So I'm putting a blank line in. So again, let me run it. Oops, not what I wanted to do. Just wanted to move it. And so you could see it's that blank line here. Otherwise, this next line that runs immediately would show up right there where my insertion point is. And that would make it kind of more difficult to see that that's actually prompting you for something, right? That's a prompt. If I didn't have the blank line, and I could do 2 blank lines or 3 blank lines, but that's just a bit of a tweak to think about how am I making this program a little bit easier for the end user. So then I have a remark right here. And by the way, in Python, we do remarks by using, and I know you all say hashtag, but it's a number sign. So we use a number sign, and then we write the remark. Basically, when you use this number sign, so let me just write a new remark. Where is it? It's Shift 3. Again, it doesn't matter whether you put a space here or not, but it is the norm to do a space. Okay. Now, it turns red immediately. The red is basically saying, this is not code. This is just a remark. We are remarking the code that follows. Sometimes we will remark individual lines of code if we have a very complex program. Most of the time, we kind of remark chunks of code because we're doing something in particular. So in this case, I'm getting user input, and I'm going to remark it another way. I'm going to say, get user input, uses, and by the way, capitals aren't necessary here, uses sentences to, that's not to prompt user for values. I could have done that all on one line. So I could have get user input, comma, uses sentences to prompt user for values. We don't need to do this. Some of you who are familiar with programming know that you should use an ending thing. You don't have to. I think in C++, that's the norm. I'm pretty sure in Visual Basic it changed to the norm. In Visual Basic, we use an apostrophe as a remark value. But you don't have to. It is not the norm in Python. So you don't have to. And by the way, in C++, you don't have to either. It's just something that became standard. So we tend to remark our code. Basically, it makes it easier for us. And by the way, I have a lot of remarks at the beginning here. And for some reason, I forgot to press space here. That's because in Visual Basic, we don't press space. There we go. Oop. Okay. Now, like I said, it worked anyway, but it's easier to read if there's a space because this is a number sign and it's more complicated than some of the other things that we use. So having said that, and by the way, this is a explanation of the program and how it works. That is kind of standard in programming.
So those are like for us, like notes to self type of thing?
They're notes to self, yes. They're an explanation of the basis that the program is working off of. Now, when I said yes, they are notes to us, they're in reality notes to other programmers. Hopefully, if we're creating a program, we kind of already know what the program is based off of, or what it is that we're doing. And again, that's kind of the little bit of a tricky part, is that, you know, we have to kind of plant ourselves into a imaginary world where there's going to be, you know, 90 people working and I'm working on one bit of code. And so here, this is exactly what this program is doing and why it's doing it. Now, some of this is a little bit, how do I put that? Froofy, I guess. Like, this is the Drake equation developed by Frank Drake in the 1960s. You know, we don't really have to give a history lesson in our comments. But because this is an example from a book and it's trying to tell us, you, the students, you know, what this actually is, it's doing that. So this is where it's saying, hey, this is what I'm using. These are what my variables stand for. Although we could, I guess, do part of that down here. I'm not so sure we actually need it, because here it's actually telling me what it is that we're doing. So let's look at, it's a bit superfluous, although I don't want to put it, I don't want to make the whole thing out to be nonsense, because it's not. We should always, maybe a more succinct beginning part, comment section, would be something like, and I'll just say it, this program calculates the amount of civilizations that theoretically could be contacted given given an equation that using the Drake equation, and prompting the user for input with sentences. That would probably be good enough. I don't really have to define all of what my variables are up here. So this is a little bit long-winded. It is telling me for instance, I would include this because there is an estimated rate of star creation in our galaxy, which is part of the calculation. But I'm assuming 7 per year because, and I'm explaining why I'm assuming 7 per year. This is actually a pretty good part. The user will be prompted to enter estimated values for the remaining 6 factors. The estimated number of civilizations will then be displayed. So this is pretty good. This is fairly succinct. I don't know if you might include this. You probably would. This is kind of a bit optional, and this whole history section here is a little bit, it's called the Drake equation, so probably I should mention it somewhere. So anyway, we've done this bit. Now we're going to talk about user input. So I'm doing 2 things. So in each line of code here, here's a line of code. So it says P equals int. Int stands for integer. Now, what is P? P is called a variable. And I've created the variable right here. So if I talk about, if I do this, this part is really creating the variable. P equals int. So what is P? Well, I made it up. It's just a random, I decided to use P. I could have used X. I could have used a name like percent of stars that have planets. So I could have used percent of stars that have planets as the name, except it'd be a little bit long to name something. And so let me tell you what a variable is. A variable is basically a memory spot that I am reserving to then put a value into. And the point is, and the reason it's called a variable, is because I don't know what the value is going to be. The value is going to change from run to run of this program. And I don't know beforehand what it's going to be, hence the term variable. If I knew what it was, it would be called a literal, right? And then I would assign a value to it right here. But in this case, I would assign a literal value to it. So I could say like p equals int, and then in parentheses just put 27. Or equal sign 27. So I would assign a value. But in this case, it's a variable. Where is the user input coming from? Oh, and by the way, an integer, int means integer. Integer means whole number. So no decimal places. If I need to use decimal places, it would be what we call a float value. So decimals are called floats. So in this case, it would be p equals float, and then the rest of the line. So we have integers and float. We also have strings, by the way, which we'll get to at some point. So there are different data types. In this case, I'm using an integer, and I'm running out of time, so I got to hurry up. Then I have input. Now, the input command basically says that the user is going to type something in. And once they press enter, then take that value and put it into my variable. So in this case, p equals int. P is actually assigned a value to hold it, and the value is 0. So p would be 0. It gets assigned a value automatically, and it's 0. It's just a placeholder. So I need to make sure that what happens, well, I don't need to make sure, but what happens after this line of code runs is whatever the user types here at the end, and notice how it says colon and then there's actually a space here before I close the literal. And you can notice that here. Everywhere I have a space right after the colon there, because that gives a well, it just puts the insertion point right there. So as the user types in, I'm assigning values to these variables. So they press enter after they've typed something, and it goes to the next line, and it runs this line. And by the way, it pauses, and it doesn't do this. Well, let me talk about how code kind of runs too. So we are taught, at least here in the United States, in most of the Western world, that we read from left to right, and that things happen from left to right. Left is the beginning, and right is the end. Well, in code runs backwards. So the way I would look at this line of code is I would look at, this shows up on the screen first. No, we don't have to initialize them separately. We're actually initializing or creating it right here. So in some programming languages, Visual Basic being one of them, it's common to just have a section where we define all of our variables and constants, and then we do value assignments in a separate step. In Python and even in C++, we kind of take that extra step out of the equation and combine it just to make it a little bit more efficient. It may make it a little bit harder to understand what's going on, but it is more efficient because we're not doing it twice. So here, this is initialized as an integer value right here. So I'm going to look at this and I'm going to say, hey, this is going to show up on the screen and it's going to stop. And the user's able to type something in. And as soon as they type something in and press enter, it's going to input that. That's why there's this command. It's going to input that user provided number into, or as, parse it as an integer, by the way. And parsing just means convert it and make sure that we see it as a numeric value, and then put that value into the variable p. So then the p will have a number. So what did I do? What percentage of stars? I said I was going to be optimistic, so I said 60, I think. 60% is what I typed in. So 60 would then go into here. And I know I'm a little bit over, but just bear with me. And then I do the same thing with how many planets. And again, I've used the variable n. F, I, C, and L. They're all integer data types. And remember, the user, once I get to this part, if I was able to stop the program, all of these variables would have user input values in them. So none of them would be 0. Well, I guess if the user input 0, they could be 0, but they wouldn't be the default value that they were given when they were initialized or declared. Does that make sense? Now I have to do that first, otherwise I can't do the calculation. Because you can't do well, you can do calculations, or most calculations with zeros, but the calculations are meaningless. So you wouldn't pull out a supercomputer and then do 0 plus 0 equals, 0 plus 0 divided by, no, you can't do divided by 0. So then you throw an error. But you see what I mean? We don't do like very complex mathematical problems or even simple math problems with zeros for the most part, because why? Right? If the answer is going to be 0, I usually don't need to do math. So that's important to understand, that we need to have values in our variables before we actually then do a calculation. So then I just calculate my result, and let me, come on, I didn't get it. There we go. Make this a little bit wider. And you can see that I'm just doing a multiplication. And by the way, P divided by 100. So I'm taking whatever value was typed in here, and I'm dividing it by 100. Why? So what does this say? I'm sorry, say that again, please.
The percentage.
Yeah. So basically, I'm converting the percentage into a decimal, right, by dividing by 100. So if I have 50%, I divide by 100, I get 0.5. And so when I do math, I have to use the decimal value, 0.5. Now, that's not being assigned to a memory spot. So it's not being assigned to a variable. So I have no floats. I'm just doing a conversion as part of the math. And I want to make sure, by the way, whenever you do math, the order of operations is very important. And we know that multiplication and division happen at the same time. So if I didn't use parentheses here, it would be 7 times P divided by 100 times N times F divided by, that's exactly how it would do the math, right? So because I've done the parentheses, what's inside these divisions happen first. So P, F, I, and C get converted to decimals first, then the multiplication happens. And I'm not converting N. Why? Because it's just a number, how many planets per star. And I'm not converting L because that's the number of years you think civilizations last. The first one is a 7, and that's a actually a fixed value, right? Because the user can't change that value in runtime. It's fixed, and the explanation is R is the number of, what is it? R is the estimated rate of star creation in our galaxy, and the estimated value is 7 per year, and that's what I'm using because hardly anybody argues that there are 7 planets created a year, or stars created a year. So that's why this is a fixed value. Now, what's this? This is the name of the variable that I initialized to hold the answer. So when this math is done, it comes up with an answer, and I've put it in a variable named number detectable civilizations. And our naming conventions state, what do they state? There's 2 ways to do this. No spaces, and then capital letters, like I did here, or underscores. And then you don't have to bother with caps. We'll talk about that a little bit more. And then lastly, I have to display my result. I'm trying to hurry. Output, I want to see it on the screen. I have to use the print command. Basically, I'm just giving myself a blank line after this, right? So basically, this is a double space. Then I do, based on the values entered, there are an estimated, and look, there's a comma here. So this is a piece of output that's concatenated, which basically means it has multiple pieces to it. So the first part here is a literal, right? It's in, oh, I did doubles here. I didn't do that on purpose, actually, but it's in the quotation marks. There are an estimated. Then I did a comma, and we use the comma to say, okay, I need to display something else. So here, I'm going to display the contents of this memory spot, the contents of this variable. And the contents of this variable is whatever the result of this calculation is. But I put it in parentheses because I want to round it. So I don't want to say there are 33,075.7 right, civilizations that could possibly be contacted, or 5.7. I want to round it to 6 or down. So that's what this function call does, is it's a round function. It rounds whatever is in the parentheses, which is whatever the result of this calculation is. It rounds it so that there are no decimal places. And then I have another comma, and we put it there. Then we put the next thing, which, by the way, you can break lines of code at commas, which is so that it doesn't go all the way to the right. So at a comma, I can break. So I just pressed the Enter key, and then I made sure that there was a tab. I think it does it automatically, but, and then this is the end of the sentence. So this is going to get put inside the sentence, inside 2 literals, let me put it that way. So that's how that works. Patrick, you do have to initialize. Oh, yeah, I already answered that question. Never mind. So there you go. So, Merry Christmas. Let me ask